Welcome to the Flux, where we hear stories from people who've asked what-if questions to better understand the world and talk about how data can help tell stories that impact decisions and create an intentional impact on the future. This is your host, John Cordier, CEO at Epistemics. In a world where the flux capacitor from Back to the Future does not yet exist, people have to make difficult decisions without always knowing how the future will play out. Our guests are people who've taken risks, made decisions when uncertainty was high, and who have assisted decision makers by using data and models. We hope you can turn lessons from our podcast into foresight so you or your organization can make better decisions and create an intentional impact for others. Today we're on with Mickey McManus. Mickey, how's it going?
It's going well. How are you doing?
I'm doing well. Bunch of travel going on as of late, as I'm sure you have as well. You're currently in Boston, headed to Pittsburgh later tonight.
Yeah, a little bit of everything.
Nice. Well, for those who are tuning into the podcast today, Mickey and I were able to briefly see each other last week in San Francisco. We bumped into each other in a side event that Mickey was the MC at the TechCrunch event. And the cool thing about having Mickey on this podcast is that when I actually first started Epistemics, I was working out of the office space that Mickey himself designed for his company, Maya Design. And I think it was on our second call, I was sitting in one of the curved rooms of the whiteboard, and you're like, are you, or I think you are?
I think I recognize that, yeah.
Yeah. So Mickey, background, one of your big things that you're known for is Maya Design. So you want to kind of talk about Maya a little bit? And
you bet.
Yeah.
You bet. A little background. So back in 1989, a million years ago, three researchers and professors at Carnegie Mellon, Joe Ballet, who was building the design program at Carnegie Mellon and built it over a number of decades. And really, some of his students were like Tom and Dave, who later went on to create this thing called IDEO when they were, students at Carnegie Tech. Anyway, he was super deep in design, the idea of form and function, and sort of how do you create a product, whether it's a digital product or a physical thing or a product that you hold in your hands or a place that you sit inside of. How do you make that a window through which you reach through to actually do what you want to do? How does the product fade away, and how does it give you a superpower, or how does it become a prosthetic to extend your reach, to kind of give you superpowers? And Dr. Peter Lucas, who was a cognitive psychologist who was studying under Herb Simon, you've probably read Sciences of the Artificial and things like that, really understood how, and he was the postdoc for J.J. Gibson, who helped create the field of cognitive psychology. And he was really interested in how people think, how people understand complex systems, and how people extend their reach from a behavioral science or a cognitive science standpoint. And then Jim Morris, who was at a place called Xerox PARC a long time back, Palo Alto Research Center. And he had worked on the Alto and the Star computer system, which were sort of the precursors to when Steve Jobs wandered into PARC and saw the Mac, and came up with the ideas after he saw the Star and the Alto that led to the Macintosh, the Lisa and the Macintosh. Jim really understood engineering and how to put things together. And if you think about it, our group was called Maya, and it stood for Most Advanced Yet Acceptable. And the idea was, could we take the most advanced technology, yet acceptable for normal people? And could we find that Maya zone, which was an idea that was coined in the 1930s by Raymond Loewy, an industrial designer who came to America and helped us kind of invent our way out of the Great Depression with this new thing called product design or industrial design. He probably had a Coca-Cola bottle designed by Raymond Loewy, or been on a 20th Century Limited train, or driven a Studebaker that was designed by him. But he would find wild technologies happening in one domain and actually bring them to other domains. And so they formed this company called Maya, and it was a two-part idea. One part would be that we'd really help tame complexity and prove that putting people first, human-centered design, for a world of unbounded malignant complexity would actually be a business. And so that was Maya, and that was the Maya Design business. and the consultancy and the lab, the research lab. And then we said we should also have a part of the effort that's really fundamental research into human information interaction. So Jim, actually, we bought Jim out a few years later, and Jim went back and became the Dean of Computer Science at Carnegie Mellon and helped build the HCI, the Human Computer Interaction Institute, which is our sort of second idea. Mm-hmm. I was not one of the founders. I joined in 2001 as the CEO and later became one of the owning partners with Pete and Joe. And we really focused on taming complexity. And a part of our business was work for hire as chips were getting embedded in everything. And suddenly we were getting on this path towards a trillion node network. All that hidden complexity was starting to get in everyone's way and not help people extend their reach. It was getting more complicated. And then another part of our business was deep research into how people might do complex decision making and things like that. And so we did a lot of work for DARPA. About 30% of our work was for the Department of Strategic Surprise, really, for DARPA, the Defense Advanced Research Program Agency. Mm-hmm. And for that, we really had to help understand how leaders made decisions, how they dealt with things in a very noisy, complicated world where you really can't ever pin things down. It's always kind of a little bit of an art and a little bit of a science, and you're kind of trying to level up from data to information to knowledge to wisdom. You're trying to move up that Bloom's kind of taxonomy, and that was really exciting work. And we ended up building a system that was wildly successful. We sent our own folks off to Iraq and Afghanistan to help deploy the system. We sold the company that we built for that effort. It was called Maya Viz, and that became General Dynamics Mission Systems. It was a part of their Mission Systems tool. And now it's used for Space Command. It's used for the Coast Guard to make decisions on, troubled waters, as well as disaster relief as well. And we learned a lot in that process about how do you build a complex system that allows end users and end scripters to be able to build new things we could never think of before. So it was a very generative tool.
Mm-hmm. So on our podcast a little bit ago, we had somebody talk about when working with those decision makers, he looks at, if you take 100% of the effort that you're putting in, the first 48% is understanding the challenge that's actually trying to be solved and getting alignment on that. The middle 4% is the modeling work, the engineering work, and then the last 48% is all about how do you build consensus on this is the strategy or path we need to take.
Yeah.
What's your take on that? And was that something when you looked at connecting with the end user or the end scripter, the person that's extending their reach, gaining that superpower? Does that 48-4-48 kind of fit the framework that you were working in?
I think that's kind of interesting. I think so there are two parts, I think, to my answer on this. One, a lot of times you're trying to build a model in your head of what you think is happening out there. And so we would work with retired generals, retired commanders. And one of the generals that we worked with was responsible for taking the green zone in Iraq, which was where the palace is and where Saddam was purported to have weapons of mass destruction and all this stuff. And the general said to his commanders, he said, look, we've got the Republican Guard. It's really complicated. We've heard a lot about how aggressive they are. I just want you to drive in and see what kind of battle we're facing. Just get in and get out. I just want to see if there's a way to get kind of a supply line into the green zone. And about 24 hours later, and so there were a lot of theories that this might take months, years. There was the potential for possibly, dirty bombs and all sorts of things and sarin gas and who knows what. And the commander that he gave that mission to drove in and drove out. And then they drove in a little further and they drove out. Then they drove all the way through and they drove out another way. And then they drove in and drove out, and they were going all over the green zone. And they were basically we're not facing any troubles. And they kept passing the palace, and they kept going in, and they go, oh, there's Saddam's palace. And pretty soon they were like, they reached back out to the general and they were like, hey, can we take the palace? Can we keep it? And he was just like expecting this to be like, months of a siege, and it basically overnight they had the palace. And so in many ways, and he described this because this is like, sometimes you got to poke the hornet's nest and find out if there are even any hornets home. And so you've got a mental model of what the challenge really is. But until you take some action, you don't know what that is. So there's always this act of, I have to poke it. In the military world, they call this the OODA loop. It's the sort of, I've got to orient myself. I've got to have an objective. I got to orient myself. I've got to decide, and then I've got to take action. And if you can get inside of the OODA loop of your competitors, think Rommel during World War II, you could basically mess up their information flow. And so one of the things we would see over and over again was that, which was sort of, you've got to learn how to poke the hornet's nest and potentially have a tighter loop than whoever you're trying to compete against. And that might be a worldwide pandemic. It could be, you're trying to get inside the OODA loop of the virus or the whatever it might be. So that would be one part of my answer, which I don't think is very different than what your other visitor said in some ways, because a lot of it was trying to figure out what was actually happening. And in some ways, there's also this planning thing that happens, which is you've got deliberative plans where you go, that next thing is going to happen. That next pandemic is going to happen. That next thing is going to happen. We could build a plan of how would we get together with mayors? How do we get together with law enforcement? How do we get together with the hospitals? We could build a plan. And it'd be nice to be able to simulate that plan and kind of like play out what would happen. Fred Friendly Seminars had this beautiful desktop simulation that they did on PBS back 70s, I think, where they would get a mayor and a head of police and a head of hospital and a head of whatever, and they would just have it on TV. And they would basically start the episode with, this horrible thing just broke out, in New Jersey. What would you do, right? And the commander, the mayor would be like, oh my gosh, I would send in the, police. And the police are like, wait, you're going to put my guys in trouble? And so just the act of simulating that also helps us learn, the psychological and the norms and then what might happen. And so and then those deliberate plans, you kind of want to get to the point where you can kind of take them off the shelf when the real thing happens and then be able to tune them for what really happens.
Sure.
So that was another part of it, which is sort of there's the plan, and then there's the planning, and then there's the holy moly, it's happening, and having a few options and having optionality. We actually built an AI system at one point for some of the DARPA work. This was something called the Command Post of the Future, and it had personal assistants that learned. It was with SRI, who had also been creating Siri, that came out of the same program. And this AI program was called Mechanical Murph, and its job was to basically throw wrenches. It was Murphy's Law, and it was basically going to implement Murphy's Law and throw wrenches and all this stuff. And the point was that if you're trying to even do a simulation, you need to have stuff go wrong. Murphy's perfect. Loosen those bolts, run out of gas, hit something bad, and this happens. And so that's kind of a part of the way you have to think about it. But if I step back, one of the things, even when we were building these tools, that I found maybe the most curious and profound was that there's this, if you look at the System Bible, there are some things that must be true of complex systems, and one of them is that no complex system starts as a complex system. Right. It starts as a simple system that can loop and be, put under evolutionary pressure of some sort. And so I think what made us so successful, and we were, we had 400% increase in decision making, 300% increase in situational awareness, knowing where the other people were at. It deployed 6 years ahead of schedule. We had to send our own people to Iraq to actually help, feed and nurture it. It was never turned off. It became a program of record very quickly. But I think the secret was that we were looking at how humans really worked. And we ended up discovering two things. One was we simulated an entire year every week, every 6 weeks. So we could take a simple system that wasn't so great and didn't have all the software in it yet. And we could have people behind the curtain doing Wizard of Oz, sort of pull the lever and make the big head talk on the Wizard of Oz, So they would sit behind the curtain and we'd test it 24 hours a day. Monday was January, Wednesday was June, Thursday was November, and we test the whole year in a week, every 6 weeks. And by putting it under that evolutionary pressure, we could see what the commanders would really do, what the leaders would do, what the technologists would expect would happen, what would actually happen. We would test it to failure. And we would suddenly be able to pull in more and more stuff. We called it the double helix because it would kind of sweep out business doctrine and sweep out technological potential out of the Carnegie Mellon labs, like the SAGE and the Visage lab. And we could pull those in, but it was based on real things. So a good example of that was one of the commanders said, I can tune in on all of my subordinates' desktops on this command post of the future. I could tune in, I could see what they're doing, but they can't tune in on what I'm doing. So they don't have any top sight into my brain. And all the other commanders were like, well, yeah, this is the chain of command. We don't want to screw up the chain of command. I don't want people going off half-cocked. I said, well, okay, in 6 weeks, why don't we do an experiment? Could 50% of the commanders volunteer to share their own desktop with everybody, along with being able to tune in to their subordinates? And 50% raised their hand, and we set up a little bit of a scientific experiment, and then we ran it. And lo and behold, the team that actually could tune in on their commanders won twice as many battles. Wow. And they started calling it top sight. They could tune in and see, oh, the commander's worried about those ambulances. I wonder why they're worried about those. I'm going to go find license plate numbers. And they'd flow the license plate numbers over to the ambulances. Maybe he was worried about improvised explosive devices. Ambulances are pretty useful for that. They get places others can't get.
Sure.
And so suddenly everyone saw oh, okay, so there's this tension between the top-down command and control and the power of collaboration. And think of top sight as kind of, if you like sports metaphors, you're dribbling down center court, you look to your left, and this guy's totally covered, but you look to your right and this guy, and you throw it to him. You're able to be more jazz. And they started calling it top sight. And top sight was this idea that if we wanted to make it a slippery slope towards collaboration. There were certain things that, of course, you wanted to have, very strict command and control kind of rules about. But the time, especially for a high-tech, low-tech kind of battle or situation, time mattered. And some of that information didn't matter if anybody knew it 2 days from now, because it's happening. So we went back in the labs and we made it so that there was more of a slippery slope. There was gradations, not all or nothing, but it was slipperier towards sharing than not sharing. And that made a big difference. And then 6 weeks later, we could test new things. And, but it was the scientific thing. We'd have the special ops guys come and they'd be behind the glass and they'd be like, well, normal army just does this, but we do this. And we're like, okay, well, let's try that. Well, we've got a test coming in 6 weeks. We'll simulate a whole year. That was useful too, because it would actually get other funding vehicles. And in fact, General Corelli, who ended up funding us to go and turn it into a program of record, he was deploying with the 1st Cavalry, who does new insertions of new technology. And he came to they were called block parties. He came to one of our block parties. And he basically was like, that's better than the $1 billion system that we have now. Can I deploy it in 3 months? And we're like, no, it's made of chewing gum and baling wire and duct tape. And he's like, well, okay, but I want to deploy it in 3 months. So then we had to shove pizzas under the door and kind of hire as many people as we could think of for QA. And Jake and Jeanette and Dr. Steve Roth. Jake was one of the founding members, and Jeanette was our best sort of information designer. And Steve Roth all deployed with it. And then, they watched things evolve in the wild. And because we had made it so easy for end user scripters, so think of the commanders that reported to the general, they're kind of like Bob in accounting, who could take an Excel spreadsheet, and Excel was like the very first purpose for a personal computer, because it was like basically a generative grid.
Yep.
And you could build like a template for collecting expenses or a template for, and so the end user scripter in that case was Bob in accounting or Al in accounting who could do this stuff, or Susan. And we felt like we needed to do the same thing. So people could build brand new tools in minutes. And then if they were dragged into shared products, other people would pull those tools out and be like, oh, John's really good at those kinds of tools. I'm going to subscribe to his shared products. And they'd pull out the tool and they'd be able to use it. And it was all what we called information centric. So if you shook something on a map, it would shake on the timeline, it would shake in the budget. There was only one of them in the universe. We just implemented Pauli's exclusion principle kind of in information space so that we didn't have the 5, blind men and the elephant problem.
So Mickey, when you're looking at creating a system like that, there's the planning phase that people might certainly utilize it for, and then there's the all plans are fine until they
the first
first contact with the enemy, or all things are okay till you get punched in the face, sort of thing. How do you see the interaction with these tools, which some people from the outside who might not be as technically literate, they're like, okay, this is all cool when we're like doing these scenarios, but I have this challenge right now. How does that shift in the way that you've seen these tools like need to evolve from a usability side of things or a visualization side?
So a lot of what happens is that when people build a really useful tool, think of a hammer. It's like, I don't even need an instruction manual for a hammer. It's got 2 ends. It's got like the hammer put the nail in end, and then if I flip it over, it's got the crank the nail out end,
And you know where to hold it. Yeah.
And you know where to hold it. Yeah. It's like, and it's an extension of you, it's a prosthetic that extends your reach. You can do things that a normal human can't do, and your body starts embodying that pretty quickly. But as people add more and more features and more capabilities and more things, they start tucking them into little pockets here and there. They start shoving them under there. And pretty soon you don't have a cohesive interaction physics. And if there's no interaction physics, then the end users have to keep this long list of exceptions, because the opposite of physics is magic. So think of, it rained yesterday and we slaughtered some lamb yesterday. So slaughtering lambs causes rain, right? The shaman says, if you just follow what I tell you, I'm slightly smarter than you because I saw the slaughtering lamb connection, and pretty soon people are slaughtering lambs in the hopes that it rains. And, that's magic. That's probably not magic. Nothing happened. That was confusing, causation with correlation and coincidence. But if you think of Windows and using a Word document, and then you go, okay, how do I create a Word document that has 2 tall pages and 3 wide pages and 2 tall pages? If I ask 10 people that question, they will give me 10 answers. They'll be like, oh, I think you have to create a section, and then I think you have to save it out, and then you have to like bring it back in again, and then you'll have, a landscape section or whatever. And that's voodoo. And so if you want people to extend their reach, you need to create what we used to call interaction physics. Like, lock it down. Physics was like, gravity was burned in at the birth of the universe. It's not open source. If I spill coffee on myself before a big date, I can't like go in and do a patch on gravity and say, if I'm ever holding hot liquid, don't, let it pour all over my good clothes. And if things didn't have a physics, like a contract with the universe, we couldn't engage our own sort of monkey brains to this. So here's an example. I've got this iPad and I've got this glass of water. And if I set the glass of water down and I set the iPad on it, look at that, it worked. Now, the glass of water designer never thought I would do that. And look at that, I could do that. And I could do that every day. I could do that on Wednesdays. I could, and it's because physics doesn't, change. And so what we would do is we would have really hard conversations about what must always be true about what you can interact with in our system. that we never break, even if we're tempted to, because breaking it, putting in little bits of magic would make it better, because software, you can have magic, you know?
Mm-hmm.
So we would build a few things that had tight physics. You know, if you ever pick something up, you could do this. If you ever did this, you could do what's called polymorphism. You could convert it to a different visualization, but you never threw away the information. You know, if you did this, a few core physics. And that allowed people to make stuff we never thought of before. Because just like I piled that up, you know, you end up enlisting the monkey brain and the creative part of it. And so I always say, if you're building a tool, look for two things. One is, how do you start with an appliance that's sort of easy enough for people to like push in the button, you know, put the toast in and it pops out toast. But then give them a slippery slope. If they want, they can pull the cover off and turn the knobs and adjust things, but don't make that the first thing you give them.
Right. Yeah.
And yeah. And I think the other part of it is just this notion of having a solid information physics, a physics interaction, so that people trust it. And the minute you get trust and it never fails, then they suddenly unlock the creative part of their ability to script.
So thinking of this like creativity, willingness to try things out, you know, trust is a big component of that. One of the things when we were talking recently, you mentioned a team that you were on called the Future of Learning team, and that was within Autodesk, I think.
Yep.
So when you look at things that you were doing within the Future of Learning team that like help people get to that, like, oh my gosh, wow, I was just able to do this. You know, do you apply that like same physics-based?
Completely, yeah.
Okay.
Well, and so the curious thing, this was at Autodesk, and so I was in the office of the CTO at Autodesk, and I was a fellow, and I helped build the Future of Learning team. So Carl, who was the CEO at the time, had pretty much decided to give away all of our software to students, whether they're in high school or whether they're in college. And so now I think 50 million kids 6 years old and up use Tinkercad. But they could also use the same tools that James Cameron uses for creating Avatar, or the same tools, you know, that Skidmore and Merrill or Arup used to build Lloyd's of London or the biggest buildings in the world. And so because we made that suddenly free, all that institutional money sales money that we were getting was pretty significant. We suddenly had to say, well, if you actually get the tool for free as a student, how do we actually help you really use all the powerful tools that are hidden inside of it? And so then we built this Future of Learning team, and we said, if you were building this glass in a computer-aided design tool, well, John, how would you start? If I said, I want you to put this glass into a CAD tool, a computer-aided design tool, where would you start? How would you start with a blank sheet of paper?
I might start with the bottom, and I might start with the shape.
Yeah, it's got like kind of a flower shape. So you might draw what's called a sketch, which is just a 2D thing, and you might know that it's like maybe, you know, 2.5 inches diameter. So you might set that diameter and things like that. What would you do next after you draw that little shape at the bottom?
Once I have the shape, I might go up the sides and try to, you know, make a cylinder.
Yeah, so you might loft it. That's a tool you could use, where you take the shape and you'd loft it to the top, but at the top you'd kind of make a perfect circle. So you'd make a shape at the bottom that was a flower, a shape at the top that was a circle, and you'd loft it. And you'd loft it probably like 6 inches, 5.5 inches tall. Cool. So I just watched you do that. I watched you use the sketching command. I watched you use maybe the mirror image sketching command to make a perfect flower, or the repeat command to make like so many petals. I watched you choose a bottom and choose another sketch at the top and loft between them. So I watched you do that. I could have little sensors inside the tool, and I could see, did you adjust the presets? Did you never adjust the presets? Do you adjust all the presets? Like now I could see, but it's solid. It's solid on the top and the bottom. So then what might you do if it was like just a cylinder that has this shape? You might want to core it out somehow, right? So you might make a copy of it and shrink it and stick it inside and do what's called Boolean, where you kind of subtract the outside in. Cool. I just watched you do Boolean. I watched you do whatever. Now it's got this like beautiful curved edge. So you might do something called chamfer, where you click on an edge and it just makes it rounded. I just watched you do that. So I've watched you now not only do a bunch of commands, I've watched if you tested and checked the tutorial, if you've done it a million times. I could also see that maybe you output that to a 3D print file. So now I know you actually made a part for it, or maybe you made a mold of it and you cast it. So I could look at your chain of commands. And so we said, what if we could build that right in the tool, and you could put in your own goals and constraints for your job, and it would generate all the pathways of learning to help you get to your next job. Oh, well, you already know how to do this. Maybe you know how to do finite element analysis. You've already demonstrated it. Unlike a resume that says you know AutoCAD, which we don't know. Did you learn that like when you were in high school and you only learned like 2 of the 1,799 commands in AutoCAD?
Right.
Or can you actually demonstrate it at all? So we said if you could use dynamic formative assessment, detect everything going on with some simple sensors, and give people a way of encoding their own goals, their own constraints. We could basically build a generative engine that would help escalate. We could see, oh, you're like 2 steps away from leveling up to 5 more jobs. Whoa, like here are 5 projects that would help you level up. Here are 2 teammates that actually know that you could subscribe to, you know. So that became what was called the learning engine. And now many of the parts are being rolled out into Autodesk tools.
That's fascinating. So there's the inspiring creativity side of things when building any of these tools or systems. How does something, when we were at TechCrunch last week, everything was an AI company now. So I'll give you the space to kind of talk about, is this large language model based world going to be helpful in inspiring creativity? To what extent? Where do these like kind of systems of magic almost, like they?
Well, I think,
like, oh my gosh, like
I have strong opinions about it. Only because we've been doing generative design or generative learning for quite a long time.
Right.
And so I've seen that in some of the tools. We had a system called Dreamcatcher that was about encoding your goals, constraints, and obstacles. And you could have high dimensions, because humans are not good at understanding how to do trade-offs across high dimensions. And you could spawn lots of agents to go out and actually explore the space, and they'd come back with some answers. So my thought about what's happening right now is AI today. When we talk about generative AI, there are like maybe 2 metaphors I would use. It's a little bit like the left brain, right brain. So that's, kind of something we learn as kids. The left brain is like analytical. I would call the analytic part of AI, that's kind of the classic machine learning. You can get predictions and process automation and pattern recognition. And we could do that all the way up to like 2017. We were getting some pretty good work there. And then this paper comes out in 2017 called Attention is All You Need. And it was the rise of what we call transformer models. And it allowed you to, in parallel, look at how every word relates to every other word, large language model. And yet, and in parallel do this so that you could cost effectively take in all the web and be able to do stuff. Now, and then we had these things called foundation models, and now there are frontier models. And there's lots of language. Visual imagery is a language, and you can diffuse in and out of it, and code is a language, and of course English and Farsi and French is a language. But you get a lot of weird stuff out of it because it's kind of trying to build a network graph, kind of like think of it as a subway graph across all of human knowledge that's been digitized. So you type in a prompt like, I'd like a painting inspired by Cubism and Picasso. So you navigate to like Picasso land inside of this giant graph of all imagery and knowledge about art. And then you go, but I want it to be of dogs playing poker. So then it goes into like Poker Town, and then it goes up to like the floor of Dogville inside of Poker Town. And then I want it to be like made of black velvet, and then it goes on to the room that is all Elvis paintings in black velvet for Las Vegas. And then it diffuses out this beautiful picture. So you just navigated through this kind of knowledge graph.
Mm-hmm.
So that's kind of what's happening. That's a little bit more like the right brain. Like you can get some really crazy things. You can create stuff you never thought of before. You can explore spaces. You can say, please analyze this, and make a haiku of it. You could do things. So there's a bit of a right brain to that. Another way to think of it, another metaphor, is thinking fast and thinking slow. So if we look at the Nobel that was just awarded to Demis at DeepMind in Google, and to the Baker Lab at University of Washington, they both won the Nobel. Their teams won a Nobel for AlphaFold and for AI to figure out protein folding. Well, that is a little different, because what they did was kind of thinking fast and slow. They did the slow part, was kind of the classic AI, the machine learning stuff that was able to actually have a neurosymbolic representation of the modules. What are the nouns? What are the verbs? How do atoms interact? What are the things that must be true based on real data? And then they did the fast part, which is a little bit more like the lizard brain. If you think thinking fast and slow, the Kahneman-Tversky kind of framing. And that is like doing diffusion models and doing transformer models. So they used both types as well. And actually, it's fairly profound what they ended up doing based on just the massive amount of data that we have now for how proteins fold from DNA. So those are the way I think of it. Will it lead to more creativity? Yes. Will it lead to new business models? Totally. More because humans. It's democratizing something that normally was locked away to only like people who could, who knew how to write code, and it took them 10 years to learn how to write code. Now anybody can kind of do that. Now anybody can kind of do stuff. So I think it's actually because of human creativity. And anytime you give humans some kind of brand new technology, brand new tool, all sorts of crazy stuff happens. And so I think we're going to see this massive flourishing. I don't care if OpenAI goes out of business tomorrow. I don't care if Google stops investing in Gemini and Anthropic stops getting any investment, or Microsoft stops. We'll still see 30 or 40 years worth of crazy creativity, both on business and on how to solve problems, just because it's an unlock. That's how nature evolves. And when nature suddenly unlocks a new capability, you get this Cambrian explosion.
If you had to, go 30 years into the future, where do you think is a new frontier that humans are going to be looking at applying these technologies to, that, whether it's large language models, agent-based modeling, these things are going to get unlocked because it's more accessible. Like when you solve the challenge of accessibility, what does that world look like in your mind?
Well, I think there's something kind of interesting. Humans are incredibly efficient. And, there's some great studies of like 11-year-old children being tested with visual prediction of agent-based actions, like how an agent would take action. Think of a pixel moving around to gatekeep somebody else inside of a prison, just an image. And they outperform GPT-4 level models as 11-month-old children. And so there's something incredibly optimized about the way our brains work. But are we the best at driving cars? Probably not. We have to pay attention all the time. If one thing goes wrong, it's like tons of material slamming from inches away into other things. Are humans great at running a city? I'm not sure. Are humans great? I think those are all things. Like, are humans great at even being a CEO? At being like, so I don't know what percentage of humans should be doing that versus what if we could be doing things that we're incredibly good at, because we are really good at a bunch of stuff. So I think I'd like to see that unlocked in terms of focusing on what our capabilities could be if we didn't have to do the stuff that's kind of mindless and toil based. I think we do need productive struggle and desirable difficulty. That's the way neurons form the fastest in our brains, is if we use it if we don't use it, we lose it, in terms of the wiring of our brains. So we're going to need, and we actually get purpose from work. So I don't think it's the end of work, and there's so much to do. Like, let's try to figure out the environment. Let's try to figure out some other things. But I think there could be a big unlock. I do think what we're going to require, though, is that we have medieval laws and we have like Cro-Magnon brains. And there's a quote from somebody that said that much better than me. Probably E.O. Wilson. But I do think we need help with, we've got lots of time management tools. We've got watches and calendars and clocks and day timers. We don't have any cognitive management tools. We don't have any tools that say, wow, John, it is 4:00 in Boston and I am completely depleted from a decision science standpoint. I have decision fatigue. Like, our meetings shouldn't be happening anymore, or whatever. Or as a group, when we walk into a meeting room, it looks at everybody's cognitive capacity and goes, you guys should be walking in the forest, and you decide to move your meeting to the forest. Like, we don't have any cognitive management tools, and each of us is different. My research partner in crime that was an intern at Cornell, who's getting her PhD into this kind of topic, Netta, she has ADHD and some dyslexia, but she had to read 400 research papers. And so, how does she do it? It's actually really tough. She has to do it in the beginning of the day. She can't work on anything else. I love reading. I get energy from reading. I'm totally different than her. So we need sort of personalized cognitive management tools. We have to treat cognition as a human right instead of sort of strip mining it the way a lot of surveillance capitalist organizations do, sort of to strip away your capacity to get your eyeballs. So I think there are whole new industries that are going to pop out. And we also probably need more simulation science, because any given human has the capacity to help solve cancer or destroy the planet. And so this democratization implies that we need to have safe sandboxes to play with. Sure. And we have to be able to play out nonlinear actions. So I think I'd love to see a sort of flourishing, think of it as SimCity 2.0 or whatever, but a flourishing of individual simulators as well as sort of system simulators.
So Mickey, I'm going to use that to go into our final two questions. So for every person that is on the Flux, we ask them to describe one of their what the Flux moments that they've either been a part of or that they look at historically and are like, you know what, this thing, if only we knew how that was going to change the world, if we went back with the flux capacitor from Back to the Future and were to change a couple of things, what would that look like? So whether it was in your career or something you'd point to historically, what do you think, if you were able to go back and reconstruct some of the decisions that were made, what would be one of the what the Flux moments for you?
Wow, that's a tough question.
SimCity 2.0, it exists. We're rewinding. We're going forward.
Yeah, well, it's actually interesting. I recently was reading Building SimCity, which is possibly one of the best books out there right now. It was written by somebody who worked with Earl Wright, who was a PhD student of a friend of mine who had recommended it to me, who also worked with Earl Wright on The Sims and SimCity. And it's actually a stunning story of city, like urban development and helping kids learn about urban development. This teacher down in LA was working with kids to kind of build construction paper towns and things. And so she was experimenting with all sorts of different ways of asking questions of how you would like to live. And she ended up on a plane one day because she was invited to run this simulation on the East Coast. And she gets on the plane and she sees her brother. And she's like, "Oh, Frank, how are you?" And her brother is Frank Gehry. Frank Gehry is a pretty well-known architect. So this teacher was invited to do this simulation city thing out of cardboard and construction paper, and run it in a DC event to think about the future of cities. And her brother, Frank, who happens to be Frank Gehry, was also on the plane, who had been invited to the same thing. And the people who invited them never knew they were brother and sister, and they basically were there. So I think partly I'd love to have been there at that moment, but I'd also love to get some of the energy from that moment and try to remind us today that it is possible and that we might be able to do something. So I'd love to see like what would happen if it didn't become this kind of thing that we just think of as a game. Although I'm sure many people really shape their lives as children to think about policies and to think about things. But I would love to see what would happen if we took system thinking seriously and we taught it at the age of 6. You know, the way that I think she was teaching, I'm blanking on her name, but we can look it up. But the way she was teaching that kind of thinking, and in my own life, we built an educational institute called Luma Institute, and it's taught over 100,000 people around the world how to put people first and how to co-create with people with human-centered design. And in the summers, we did pro bono work where we would volunteer to teach the workshop. It was kind of an executive 3-day tool workshop on kind of human-centered design and co-creating with people. Mm-hmm. We taught it to inner city kids in 5th and 6th and 7th grade in Ohio and in steel towns like Elizabethtown and things like that. We would teach at places. Mm-hmm. And you would see these kids light up. We would do it for 5 days. And it was funded by, various folks, foundations. And you'd see these kids, like we taught them how to make prototypes, and we taught them to go next door and look at the community center and learn about a real problem the community center faces. So don't design for themselves, design for someone else, subvert yourself and take on someone else's needs. And they would prototype, and they were sanding and making things, and then they would test it with real people, with Wizard of Oz prototypes and things like that. And these kids were, middle schoolers. And at the end of the week, because we interviewed them at the beginning, at the end of the week, some of these kids said, "You let us make stuff. You let us make stuff." And something about that just kind of broke my heart, because it was like, it's like, because we've treated everybody so much like you're just a consumer, and the only thing you can do is consume. You get a thing and you use it. Mm-hmm. That's it. It ignores the joy of breaking stuff and making things and unlocking and taking apart things. And so that's the other thing. It was an aha moment for me that made me think, wow, what do we do where we beat creativity out of kids until they're about 30, 35. And then we're like, we need people to be more creative, in business or something. So I'd like to see us double down on that.
Awesome.
That's my What the Flux.
That's a What the Flux moment for sure. So final question for anybody that wants to get into decision science, data-driven decision-making, thinking about building SimCity 2.0, where do you recommend somebody start when they're in high school or undergrad and like looking at, what do I want to do when I grow up? How would you recommend they start?
Well, I would say I'm a big fan of both First Robotics, which Dean came in and Woody Flowers created, and that notion was kind of in there's Lego League at the lowest level, and then high school and college, or really I guess to high school, and then iGEM, which is the International Genetically Engineered Machine Competition, which came out of MIT as well, and it was a similar kind of effort but around biological stuff. I just went 2 years ago. I went to the Grand Olympics in Paris of iGEM, and there were inner city kids. Again, I grew up in the inner city. I went to a public school, so I always gravitate towards the kids that are just like kind of people that would remind me of me when I was a kid. And they were designing E. coli organisms that could tear apart explosive materials and pull apart bad things and stuff, because they lived in Puerto Rico, and there was an area that was used for bombing by the military for so long in the lagoon, and everybody had high rates of cancer, and they were like, we need to solve this. And the reason I bring both of those up is that it was pretty stunning. The winning team was from Atlanta, Georgia, and it was a public school, and they came up with this beautiful way of detecting precursor to heart attack, in the blood by doing different kinds of things. But the reason I bring it up is because you can't really build complex robotics, so First Robotics, or organisms, or even learn about booting up organisms without having a really deep appreciation for systems. And I think nature is possibly the most glorious system. Like even to this day, we think genes are one thing, and it's turning out almost every day we're finding out genes are not what we thought. Like there are genes that are not made of DNA. There are genes that are made of RNA. There are genes that like modulate and create 72 different proteins, not one protein. You know, we used to think the central dogma was a gene led to mRNA led to a protein. Totally not. It's like this pool of craziness and stuff, but it forces you to step back and see the system. So I would encourage people to take on some of these things that have such glorious complexity that you almost have to have system thinking. And it's also humbling because then you've got a big space to grow.
Mickey, that's awesome. I just want to thank you for taking the time to jump on the podcast.
Thanks for having me.
I think this is a very important one for definitely younger folks to listen to, but also when you're looking at fostering creativity within an organization, like you just got to let people build things. Yeah. I
would say 3 book recommendations. I already made one, Building SimCity. Mm-hmm. Number 2 would be
already ordered it since on the call.
Number 2 is The Nature of Technology by W. Brian Arthur from Santa Fe Institute, and Scale, also and by Jeffrey West from Santa Fe Institute. All 3 of them are all really about systems, and they're sort of glorious in different ways. Scale is about some sort of hidden scaling laws of cities, of organisms, and of organizations. And they're different scaling laws for each. And The Nature of Technology actually peels apart what is technology when we say technology and how does it evolve? And they're pretty profound.
Cool. Whenever this gets posted, and for everyone else listening on, there are links to these.
Let's put some links in.
Yeah. Onto the transcript. Well, Mickey, thank you again so much for jumping on.
Yeah, thanks for having me.